$28,000 a month. That's on one client was paying on API cost. And that was not infrastructure, not salaries, just plain raw API cost. And as you see on the screen, we got the number down to under $7,000, all with the same features, the same users, and the same quality. That's around 75% less. And here's the thing, this wasn't some magic model or secret technique. It was just 3 layers, pretty simple: meter, cache, and route. And today, of course, I'm going to walk you through exactly how each one works and trying to explain deeply the process and the logic behind. So here's what happened. A client came to us. They have built this AI-powered product, customer support, internal tools, document analysis, just the usual stuff. It was working great, users love it. But the API bill, it kept growing every single month. And they were not even budgeting for this. And nobody could explain why it was growing like that. Of course, they had a growth in users and everything, but they couldn't justify the growth, at least on the bill. And turns out that they were on GPT-5 for everything. Every single query, no matter how simple, goes straight to that expensive model, because GPT-5 is an expensive model if we compare them to other alternatives indeed. But the point here is that the engineering team knew that this was a problem, but they had no idea where to start. Their argument was that we need all of our queries to be high quality. And I understand, you don't want to give user bad answers, right? But here's what nobody had actually done. Nobody looked at the queries, right? Nobody sat there and said like, hey guys, what are the users asking? So this is how it was working before. All of your queries sent to GPT-5, they were just spending a ton of cash. So the 3 layers I spoke about at the beginning. First one meter, second one cache, third one drop. So the very first thing we did, before touching any architecture, before writing a single line of code, we instrumented the API call, every single one. We tried to find out what's the prompt, what's the response, how many tokens, what's the latency, and what's the actual cost per call. This is really important. This is not complex, it's not fancy, this is not over-engineering, this is not like, wow, this guy came with a really cool idea. Because it's not, it's actually pretty simple. It's basically a middleware wrapper, 40 lines of code maximum, that's it. You just stick it between your application and the API client, and every call gets logged. With this client, we ran this for 2 weeks. We didn't change anything else. And what we found after those 2 weeks, it was a little bit embarrassing of how obvious it was. But again, nobody had looked at the time. The thing is that 80% of the API traffic was just variations of the same 12 questions. That's it. 12 questions. Customers asking the same things, worded slightly different over and over and again. And every single one of those was hitting GPT-5, generating a fresh response and burning tokens, which is great. Which questions you might wonder, alright? So we have on the screen, like, what's my balance? Show me my balance. How much do I have? So those are 3 different prompts that at the end will reproduce the exact same answer for a user. Those are 3 different API calls. That's basically where all the money was going, right? 80% of that. If you're watching this and you haven't instrumented your API calls yet, do that first. It's very important. Don't try to go and try to optimize blind. You really need to understand what's happening behind. On the screen, if you're a developer or if you're used to work in tech, you know that if you see a 200, all's good, right? But with AI applications, if you see a 200, you are not understanding what is happening behind it. And this is really important. You need to understand and be able to explain how things are working, what is going on behind it. You will be surprised what you will find after you do this. Like, believe me, we solved previously similar cases. Pretty much they were all the same. Like, we did and implement very similar solutions. But with this client in specific, I was really surprised that 80%, it was just 12 questions. Okay, so now we know the problem. Most of our traffic is repetitive, so the obvious move is caching. The thing with this is that you can just do normal cache with LLM queries. Traditional caching is exact match, and that means that the same key and the same value should be there. But when we are going back to the questions, what's my balance and show me my balance, those are completely different. A normal cache will miss that completely. So what we built instead was a semantic cache. Here's how it works. So when a query comes in, you first convert it to an embedded. Basically, a vector that represents the meaning, all right? Not the exact words. This is really important. Now, and if the similarity is above your threshold, you just return the cache response. Simple. If not, then just goes to the model and you store the new result for the next time. So it's pretty straightforward. You could use timecode, you could use quadrant, whatever you prefer. The point here is not the tool, but it's the way of how you're solving this. And here, and this is really important, let's go back to the similarity, because the similarity matters a lot, believe me. So if it's too low, and you start returning wrong answers. But if it's too high, and you will not start catching enough variations of the query. With this client, we started probably around, I believe it was 0.97%, and we barely caught it. Then we dropped it to 0.95. Take in mind that this is just 0.02% of difference. The cache just went through the roof. So 0.02%, it made a huge difference. And what were the results with this? So within the first week, we were already hitting a 60% cache rate. 60% of API calls just gone. Those 60% that were just going to GPT-5 every single time were non-existent anymore. At least we're not sent to the LLM. So that's way better than 100%. And the thing with this is also really interesting, is that the answer we're getting faster. I mean, if we look, of course, here says cheaper, because it definitely is cheaper than sending every single query to your most expensive model. But the point here, and what I like the most, is that it's faster, and we provided to the user the same quality. So at that moment, we eliminated 60% of the API costs that were going straight to GPT-5 in one way. But we still have 40% that are being sent to GPT-5. And I need you to pay attention here, because this is really important. The road part might sound very simple, and it might sound obvious, but this is really hard to get right. And I'm telling you this because with previous clients on similar cases, we had the same problems, and we were like, oh yeah, this is very, very easy to do, but it's not. And the idea here is pretty straightforward, that not every single query needs the smartest model. When a user is asking, what are your business hours? That doesn't need GPT-5, okay? Very simple query. But a query that asks you to analyze a complex legal document and summarize the key risk of it, that definitely needs a big model. You can talk about GPT-5, you can talk about Opus, bigger model if there is any at the moment you're watching this video. So we built a complexity scorer. And this is important. This is the part that I ask you to please pay attention the most, because this is not just keyword match. So we tried that first, terrible experience, don't do it, I don't recommend it. But the main reason for that is that the simple looking queries sometimes need deep context, and complex looking queries are sometimes just long, but totally straightforward. So instead, this coder look at the combination of signals on how many entities are in the prompt. Does it require reasoning across multiple documents? Or is it a known pattern we have already seen before? And is there domain specific terminology and need a specialized understanding or a fine-tuned model? And then, based on that score, the query goes to one of three tiers. The tier one, simple queries, these go to a smaller, much cheaper model. For this client, we fine-tune a model. Some people might say, hey, why you fine-tune for this? You can just use an off-the-shelf open source model like Quen, 4 billion parameters, that's enough. And yes, I might agree with some cases it's more than enough, but when you have clients that they really are trying to provide and standardize quality, it's better if you fine-tune for this. So the problem is that these models, as they are small, even if you use the same prompt, their output might differ from time to time. And if you want something more standardized, something that the users get used to, something that the users enjoy, that they like, it's better if you fine-tune. And you don't need for these millions and millions of data to fine-tune. People have the idea that you need an enormous amount of data, and it's not like that, okay? So 10,000 examples, sometimes even 1,000 is more than enough to help a model to understand how to reply and what to do on certain situations. And the cost for this was nuts. It was just like a fifth of GPT-5 per token, right? It was really, really cheap. And it handled simple type of questions perfectly. Okay? The users were satisfied at least. On tier 2, we have moderate complexity. This go to a mid-range model. Of course, we can not talk about GPT-5 and Opus. If we are comparing on a scale, I think the best example is Anthropic. They have Haiku, Sonnet, and Opus. Mid-tier models, I will classify Sonnet in that, just to give you some idea of the level. Or you can also scale with billion of parameters, but to give an example. The tier 3, the hardest stuff, like where you really need complex reasoning, multi-step analysis, this still goes to the top tier model. If we go back to the Anthropic example, this will definitely be Opus. But now we are talking maybe 15% of total traffic instead of 100. I'm saying 15 and not 8, because take in mind that some of the queries that were not in cache, they might go sometimes to this tier 3 model. Here is something people really don't expect, and is that the routing itself is quite cheap. It's pennies compared to any other model in the market. The complexity scoring uses a tiny model. It's not going to be over or around, or not even close to 4 billion parameters. It's something that you can run easily in pretty much any device, any computer if you want, any server. So that's cool. Or if you don't want to use a model, just heuristics for common patterns, I think is more than enough. We have implemented this with some of our clients and it worked great. So it more depends on the results you see while testing. So the Godus routing is absolutely negligible compared to what it says. This is important. This is what I'm talking about testing. system because you need to understand what works and what doesn't. Let me put together all the three-layer system, so it's going to be more visual. What we have here, let me go step by step. A query comes in, the meter logs the query, so we always know what's happening, then it hits the cache, and if we have seen something semantically similar, we just give an answer right away. There is no step further than this. But if we miss a cache, and then the router scores the complexity and sends it to the right model, the three tiers I explained before. So our response things come back, guess cache for the next time. Remember, meter, cache, and route. That's it. 3 layers, no more. I already explained the full technical part, I would say. So let me walk you through the numbers. So before the client was paying $28,000 a month, every single query going straight to GPT-5, and they had no visibility and no optimization whatsoever. And the product was the same. The features were intact, the users didn't notice any difference. Actually, response times got faster because of the cache hit. And users love it because the majority of users were asking the same 12 questions. But of course, over time, we are catching more and more queries and we know what to do. So response were getting insanely faster. Users like a lot. Okay, and let me go back here on the percentages side so I can talk about it. 60% of the queries never touched a model at all. They were all on cache. 20% went to the cheap tier, and only about 8% of all traffic, if we skip the mid-range model, only 8% were going to GPT-5. But take in mind that before, 100% of all queries were going straight to GPT-5. Okay, and this system worked. But if I will start doing this from the beginning for this client, that let me clarify this as well, we were not the ones who implement their AI ecosystem. These are the 3 things that I will do different. Start the meter on day 1. This is the first one. Not after the bill is already a problem that you start thinking, hey, maybe the bill is a little bit too high for what we expect. But the moment you're making API calls in production and even on testing, you should be logging them. This is very important. I tested to you before. It's like 40 lines of code. There is literally no excuse not to do it. The second thing, and this is really important, at this time I know this, but when I started doing this type of implementations long ago, I had no idea about this. And I would love for someone telling me this because the complexity coder needs ongoing maintenance. You have here 2 ways to do it. You either maintain the complexity coder from time to time, or you either make it so it can learn so with time. Learning new patterns without forgetting relevant past data. This is very important. It's not like you said this, you forget about it for a month, and that's it. No, because the routing accuracy will start to drift a lot and you will just get really bad response. You need to review this monthly minimum. And the third one is that the cache needs proper invalidation log. This is key as well, because we actually had a situation where the underlying data changed, but the cache responses were still being served. And users indeed start getting still answers, and this is really bad. So for this client, we added TTL and a manual invalidation hook for data updates, and this as well should be there from the very start. And if I'm honest with you, the hardest part of this whole project wasn't even the code. This was the easiest part, but the hardest part, it was convincing the team that using GPT-5 for every team, it wasn't a strategy. It was just the fault that nobody had ever questioned. And I understand that many people base like, hey, let's use the biggest and most powerful model just because it ranked really high on X benchmark, but this is really bad. I would love to do it, but in an ideal world where you don't pay for API costs. But at least I'm not in that ideal world, and I haven't met anyone on that ideal world, so this is really important to take in mind. And the thing that really stuck with me in this project, it wasn't the cost savings. It was that 80% of production AI traffic was just 12 questions. As I said to you, this is the first time I saw something like this, just 12. That's why I wanted to make this my first video. So we spent weeks building sophisticated cache and routing and all these cool things I show you. But the real problem, at least, it was much simpler, okay? And it was that nobody had looked. Nobody had sat for a second, think about what their users are asking. And their most expensive mistake, I will say that it's not even the architecture they choose, but it was the assumption that every query was unique. So if we saw the questions, it might be like, hey, yeah, maybe the queries are different, but they're all looking for the same answer. And that's the point here. So if you're running an AI in production right now, go look at your log immediately. I mean, literally sit and look. You can use AI as well to analyze the semantic questions, or the intent, I will call it. This is more important, the intent of the query. And you might not like what you find, believe me. You will be very surprised by what you find there. And as I said before, this is my first video, but I hope that more of these are coming. So yeah, subscribe if that's your world. Cheers.